So this is an extreme example actually, but I hope it shows the value of micro-benching. We've established then that version 2 of our code looks to have significant performance improvements compared to version 1 of our code, at least when it's run in isolation in this separate testing system that we've just built here. The obvious next question is, will this make our application run better or worse when we deploy this change to our main application? Now again, there's no obvious answer to this. Changing one piece of code within the application might have a knock-on performance impact on another piece of code, which means that the overall performance could deteriorate. To evaluate that, we need to calculate what's called a macro benchmark. That is to assess the performance of a small piece of code, but we're assessing it within the context of the entire system where that code is being run. The principle of what we're going to do here is exactly the same as a micro benchmark, but for the fact that we will now allow the Java virtual machine to do its native compilation as it sees fit, and we'll need to choose a sensible measurement. Now, the word sensible in this context is really up to you to define. It could be that you might want to exclude the startup time and only start your measuring after the application has started, for example. But I think in our example, because what we're trying to do is calculate a number of Fibonacci primes, let's just go back to that project. I'm using the improved version here. And what we're trying to do is find 100 Fibonacci primes and see how long it takes to find those 100 prime numbers. Well, I think it would make sense to say, let's just try and find 8, because we know that it can find 8 in a reasonably short amount of time, and we'll see if it makes a difference in how long it takes to find 8 of these Fibonacci numbers. So let's make some changes here then. I'm going to change the target, which is the number of Fibonacci primes we're looking for, to be 8. And just before I go any further, I'm just going to run this just to make sure that it does stop when we've reached 8 numbers. Okay, well, that has happened. We've got 8 numbers. The job has stopped, so that looks good. And so what I'd like to do then is to find out how long did it take to get to that point. I'm going to start measuring, I think, right at the start. And we'll get the end time as well, and we'll just print that out at the end here. And actually, I'm going to be lazy and copy the print line from the previous project. Okay, so I think that's all we should need to do to be able to do this measurement. So we currently have got version 1 of our prime numbers. Let's run this and see what happens. Okay, well, that took 8,487 milliseconds, or about 8.5 seconds. We probably should run this a few more times to see that that's roughly what it takes every time, but we'll work with that. 8.5 seconds for this version. Let's go now and change our number checker to use the second version, the isPrime2 version. So I'm just going to copy out the code from there, go back into the version of number checker in the Fibonacci primes project and paste it in. And we just need to change the int here to an int as well. And then we're ready to rerun this project and see whether we get something that is quicker than 8.5 seconds. And, well, I think that's very interesting. It's taken longer. It's taken 9.2 seconds. So interestingly, this one optimization that we have done appears to have not been an optimal solution within the context of the wider project. I'm just going to run it one more time, just in case that was a bit of a fluke, and see if we get the same sort of response the second time round. And again, well, it's definitely still taking longer than the first version of our 8.5 seconds. So interestingly, the change that we made in isolation as a micro benchmark has turned out to not necessarily be a good change when we run it as a macro benchmark. So why might that be the case? Well, to answer that, we'd need to load up our profiler and see what's going on. It might well be that we've optimized a method, which means that there's more pressure now because this method's being performed more quickly on some other method within the system, and that other method is causing the system to run much more slowly. This is the reason why benchmarking may not necessarily always be the best idea, certainly micro benchmarking. It's vitally important that you macro benchmark, that you test these things within the context of the project. Okay, well, I'm going to leave this here. I did say that in this chapter we were doing a quick and dirty way of benchmarking. In the next chapter, we'll look at a more robust way to evaluate code performance.